Hello, this is a remake of a class that we did last Friday where I had some technical issues, and so I'm doing this screencast again so that you will have access to the material. The topic today is Introduction to Python. We're transitioning from MATLAB, where it's primarily a technical computing environment where people will often work primarily interactively, to Python, which is really a widely used tool for software engineering. And Python also has very good capabilities for technical computing as well. And so a lot of the lecture today will focus on the transition from MATLAB to Python, especially pointing out a lot of the characteristics that are similar. One of the other things I hope that you'll be able to get from this is a sense that there is a lot of similarity between different programming languages. And once you've learned one, then you will know others. And as an example, we'll do an adaptation or a translation of the prime numbers codes that we developed in MATLAB, doing that into Python. And of course, there'll be homework as well. So let me continue with the Python environment. And there's a lot to choose from here. So at this point, you should have already installed Python. There's a Python package called Anaconda. You should have installed that, and IPython notebook as well. I'm going to start with a little bit of history about Python. The man you see pictured here is Guido van Rossum. He is the inventor of the Python language. It turns out that Python was so central to Google that Google hired him a few years back. And so I didn't have direct contact with him when I was at Google, but it was great to know that he was a colleague there. Those of you who have much contact with computer scientists will find that the choice of programming language is probably one of the areas where there is the most passion. And Python is certainly no exception to this. There was a whole credo developed around Python and something called the Zen of Python. That these were sort of the premises, which are somewhat abstract and philosophical statements, but certainly very desirable about what the language was supposed to achieve. So if you want to find out more about Python, it is an open source project. And anything with the .org is open source. You'll find more of this at the Python website, python.org. Provide a lot of information, background, and also ultimately this is a great source of information for various kinds of downloads. So let's talk about a few of the environments. So the simplest environment that is available to anyone who has a Mac you have to do a bit of an install to get it on Windows is the command line. And at the command line you would type in simply just Python, and then you enter in this environment that typically you're going to have these three greater than sign or carets. You type in some commands that are valid Python, and you get answers as a result. So here what we did is we typed in the string hello world. It came back with hello world. In Python, you can either use single or double quotes to indicate a string. The next line is an assignment statement, a equals 3, b equals 4, and then we're doing this arithmetic computation, a plus b, and Python correctly comes up with the answer 7. So, and then to exit this environment, you type in exit with parens. It's actually a function in Python, and that causes you to leave the environment. So another environment that's available to you, and this does not require any installation on your part, is to use Sage Math Cloud. This is developed at the University of Washington, and we had mentioned this before with providing access to MATLAB and Octave. And so Python is also available in Sage Math Cloud. You create a terminal and you type in Python in the same way that I showed you before. And it's giving you a similar kind of interface as well with the three greater than signs. By far, the environment that I will use most frequently in this course is IPython Notebook. And this is one of the installs that I hope that you've already done. IPython Notebook creates an environment in which it's very easy to enter commands, replay commands, and also get access to help. And I'll take a bit of a sideshow right now, or a sidebar, to then show you an example about how you do this. So this is something you separately have to install. You look at the software tab on the course web page to get details about this. And once you have IPython installed, then you would go to a terminal session in the Mac, a command line session on Windows, and you type in IPython notebook. Now, IPython notebook actually runs as a web page on your browser. It actually runs in a tab on your browser, actually a few tabs. And so what will happen next is you'll see a lot of flashing around, and this terminal session will disappear, and instead will be in a browser tab. So let it do its thing for a second or two, and should come back in just momentarily after it finishes thinking. And then what we should be able to do is then we will have a new tab on the web page. I'm going to bring this out so we just see this tab. Let's see here. There we go. So now just have this tab. So this is what happened, and what it did was it's running IPython notebook in the directory, at the directory where you invoke the command. So I invoke the command in a directory that has something called lecture 8, which is some of the notes I'm going to use in IPython notebook. I also have something here called untitled, which I'm going to get rid of. And just press the delete key to get rid of it. Confirm that. For right now, rather than using my prepared notes, I'm going to create a new notebook just to give you a feeling for what's going on right now. So, like I said, the sequence was you type in IPython space notebook at a command prompt for the appropriate operating system you're working with, and it will bring up this tab in the web browser. Now you press New Notebook, and now you're actually into IPython notebook, into a notebook itself. So this is a brand new notebook. So IPython is organized into a series of cells that you can order in any way. Cells can have both input and output. So right now we're seeing an input. We'll do the kind of thing we saw before with the command line. So if I type in hello world, and then should mention that there are a couple ways you can do the activation here. To make this visible to you, I'm going to press this run cell key command right here. So if I press run cell, what it does is you see the result that comes back is hello world. It uses single quotes, but double quotes are also valid strings. So this over here, and you see the frame around this, is one cell. And this is the input part, and this is the output part. Now, if I could do the same kind of thing, let's try and repeat what we did before in the command prompt. Let's say A equals 3, and then if I press just return, that gives me a new line. So I've actually expanded the input part of the cell. Now I get another line. B equals 4, and then I press this again, and I say A plus B. And now when I press run cell, it's going to run all three of those commands at once. Whereas before, in the command line environment that we saw in the Python shell, is what it's called, that actually, every time I entered a command, it would run it. Now it's going to wait until I press this run cell before all three of those commands run. So you can see then it comes out with an output of 7. Okay, now, there is a faster way to do this, if you like. So instead of, let's say here, A equals 3, let's say I'm going to make that into A equals 2. And so instead of going up here, sometimes people find using the keyboard a faster way to do a lot of this. And there are two ways you can enter this command. So one of them is if you hold down the control key and press return, then it will run the command. You can see that the 7 went to a 6. So I actually run the command. And I'll show you this again. I'm going to make this a 1. Now, that's if I held down the control key and the return. That would just run the command. A lot of times I want to run the command and create a new cell. If I do that, I press down Option or Alt, depending on your keyboard, and I press return, And you see now that actually created a new cell over here. The cells are numbered. You can renumber them. The other thing that's nice about the numbering is, and the order here, this is a feature of IPython Notebook. What the thought is you're going to use this notebook to actually prepare a kind of a lab report and of your computation. So you may want to organize things differently. I may want to have this cell 4. It's numbered 4 because it's the 4th thing I entered, not because it's in sequence 4. I may want to go up and down with it. So these commands here allow me to move this up and down. And notice it moved the entire cell, both the input and the output portion up. Now the other thing, of course, I may want to do at the end of the day, I may decide, gee, I'd like to renumber everything, starting from 1. And the way you do that is you go to this kernel part, you say interrupt, and that will stop it. It says interrupting kernel, now it's stopped. That's make sure that IPython Notebook is not running again. And if you say restart, restarting the kernel, okay, so now it's restarted, and now what I can do is just run all the cells, run all. Okay, so now I've renumbered, and I'm not sure I ended up with 2 2s over here. I guess it's because nothing's been entered there. Let's see what happens when I enter something. Let's say, let's do B times C. And once again, I'll show you what I'm doing here. Okay, so that's sort of interesting. Oh, okay, and we got the error because, think about this for a second. Why did I get an error? I got an error because C is undefined. Okay, so if I instead name this C, and I'm going to rerun that cell, so I'm going to press the play there. Say, now that becomes 4 because that's the 4th thing I've entered. And now if I do this and then press the run cell, then I get something meaningful. Okay, so that's the basics of using the IPython Notebook. If someone gives you a notebook, like I will give you a notebook from a class interaction, then what you need to do is you just rerun that. You're going to have to rerun that notebook in entirety to get the same results at the end. As opposed to just running each cell at a time. So for example, if I stopped this notebook, or let's say I just save it. Let's save it first. Oh, that's an important thing to know how to do, is show how to save. So typically you want to rename it to something meaningful, and we'll call it fun in lecture 8. Lecture 8. Okay. So that's the name of my notebook. Okay, and so suppose then I want to just get out of this. So I'm going to close and halt the notebook. Okay, leaving that page. Leave it. Okay. All right, so now when I come back to this notebook, I can re-enter it again. This is the notebook that I had just created. Re-enter it again. And now if I press down here, if I said, what is C? If I want to just press see what C is, or let's say A for that matter, and I say play. Say that's unknown because I haven't run the notebook yet. If if I just run this cell right here, actually, let's say I just run this this cell here, hello world, that will give me the same result back again. If I want to run all, then I would do this, and if I run all, you see now I can type in A, and that's meaningful. I could also type in C, and that will get me something as well. C is fine. Okay. All right, well that's enough on the basics of IPython Notebook. Let me return to the main lecture over here. All right. And okay, let's continue here. So that's IPython Notebook. I gave you some of the basics about what a cell is, and these are the reasons why. You get to record your interactions, you can document what you're doing. You can actually put in text and in something called a markup language. Allows you to rerun things. It's often the case that you'll try several different variations on a computation before you find something that works well, and then you want to sort of organize that, do it as a sequence so that then you can share with others, or have it then be saved and run it later on as a function, a Python function or a script. Okay, so now let's move on to what is Python and the elements of the Python language. Okay, so much like we structured our discussion of MATLAB, we'll just structure Python in the same way. And this is because really there are so many similarities between programming languages. Once you understand one programming language, it's generally not too difficult to be able to make your way through another programming language. And I use the phrase make your way because there are usually special features and capabilities in a programming language that you don't become aware of unless you think a little differently. And we'll see that with Python, going from MATLAB to Python. There are definitely some differences. So a lot of the focus I'll have in Python is on types, what we call data types and data structures in MATLAB. But the term type is more commonly used in Python. And one of two of the key types are lists and dictionaries, or DICs is the name they use. Once we get on to flow control considerations like if and for, it looks pretty much the same as MATLAB. The syntax is a little different. I mean, I say it looks. The syntax is different. The syntax does not look the same. But the concepts are exactly the same in terms of what an if does. You're testing a condition. If that condition is true, then you will execute a block of code. If it's false, you don't. And similarly with iteration, you do something repeatedly for a number of times based on what's called the termination condition, like the number of iterations, how many times you loop, and within the loop there's a iteration variable. Scripts and functions, conceptually it's the same, syntax is a little bit different. So let's talk about the basic types. We've already seen string, we've seen integer, we've seen float. Boolean is the same way. The interesting thing about Python, and let me go back here. Actually, this is worthwhile doing for a second. We'll go back to our IPython notebook. Make sure I'm getting the right one. Yep, I want that. Okay, IPython notebook. Okay, so actually, no, I'm going to close this one because I want to keep a record of what we're doing. Or actually, I don't have to close it, but I'm going to open up the one with my lecture notes in it. Okay, so this is like before, like float type equals 4 is 3.4. If I created a new cell here, let's say right here, do a plus, and I said, here I had this variable float type. What's going to happen when I type in float type to this notebook that I just opened? What's going to happen? You know what's going to happen. It's not going to know anything about it, so that's going to be undefined. It's not until I execute this cell that now I can go back here and execute this cell, and it will be defined. So hopefully that part is clear. The text here, this text is actually in a cell. So all I did was double click on that. You see that's a cell. The difference is you see this up here, this cell type. It's called a heading. It's a heading cell. So if you execute or run a heading cell, it produces this kind of text. All right, so we're talking about data types here. We see that you can have a string as a string, okay, and then you can have another string over here. And then if you run that cell, you see you get the value of the last value produced. So this produces the value string, in quotes. This is produces value another string, in quotes. You can use single or double quotes. It's just the last one that appears. As in MATLAB, a semicolon at the end suppresses the output. So a lot of times that's useful. All right, so let's see. And I mentioned there's a special type. And that type is called none. And that's really useful in science because a lot of times something is unknown or undefined. And you'd like to say that explicitly as opposed to assigning it a special value, like if it's a float, saying that it's -1. Well, is -1 really an invalid value? I mean, sort of depends on the data that you're working with. Do you use 0? In Python, you have this nice capability to just say it's none. So you can say A equals none. And that's a valid thing to do. That none is actually a variable that's assigned. And now if I create another cell up here, and that's not what I wanted to do. Let's go up, because that's still here. If I create a cell right here, and I say A, it should come back. Oh, that's interesting. It's not printing. Maybe I have to say print A. And maybe that will then get me what that A value is. And it says that it's none. Okay. But that's really for the basic types, that's really about it. Let's move on to lists. Lists have a lot of similarity with MATLAB matrices. There's a little more flexibility. There's a MATLAB concept called an array, which is probably very close to what a list is. We didn't talk about the MATLAB arrays, but we talk about lists, and you'll see that in comparison to what we saw with matrices before with MATLAB, this provides you with a lot more. So the way you define a list is using square brackets, and you separate the values in the list by a comma. So here we have 1, 2, 3. I'll add on a 4 just because make this really exciting. Get a 4, and then we'll run that cell, and then we see the result there. The way you address it, okay, so now this is an important point. This is the kind of thing that just varies from programming language to programming language, and that is how are elements indexed. So in MATLAB and Fortran, you index from 1. So this value of 1 here, that would be A1. But in Python and C and JavaScript, you index from 0. So the 1 there is A square bracket 0. Okay, so think about this for a second. Okay, what would this element here be? Right there. Okay, and that's going to be this, of course. So I'll run that cell, and we'll see it, and that's what it is. Okay, now, if you want to make a matrix in MATLAB, that's in Python, it's actually it's a different concept than what we think of in MATLAB. Similar to, if you looked at MATLAB arrays, there's a similar kind of idea, but in Python this is very natural, and that is that a matrix is really a list of lists. So here we have this matrix, I'm calling it MAT, and it's going to be a 2 by 2 matrix. The first row is 1, 2, the second row is 3, 4. And the way that's done is by having at the top level it's really a list of rows, and then each row we're identifying separately. So here's the matrix. 1, 2, 3, 4 is 2 separate lists. And then if I want to then pick up the second row, it's indexed by 1, remember, because we start with 0. And if I want to pick up the first element of the second row, so that would be this 3 over here, it would be the same thing as saying 3, 4, I want the 0th element, because that's the first element. Now, let's go back to the beginning. Suppose I wanted to pick up the 3 out of this matrix. So I have to pick up the second row, the first element. So you would do multiple levels of indexing. For each level, you have nesting of the list. So here we would have a square bracket 1, that gets us the second row, that gets us this row. Square bracket 0 gets us the first element, and that's the 3. So let's think about this for a second. I'm going to, let's get rid of this for a second here. And let me just rerun this so that we clear out that cell. Yeah, cleared it up. Great. Okay, so let's look at this matrix over here and think about this is a new matrix, MMAT. And MMAT has, it's a 3 by 3 matrix. We have 3 rows. The rows are indicated by these lists here, and the values within the rows are within the particular list. So if we wanted to pick out, let's say the 7. Let's do the 9. We're going to do the last one over here. No, I changed my mind. We're going to do the 7. Pick out the 7. Okay, so let's type in, let's figure out how we're going to do that. We're going to pick out the 7. And to find that 7, we have to pick the first, second, third row, or third list. But that's really 0, 1, 2. So that's a 2. And then we want to pick out the 7. That's the first element. Well, the first element is really 0. So that should get us a 7 if we run that. Okay, now what did I do wrong? Everybody know what I did wrong here? I did not run this cell. Because I didn't run this cell, it's undefined. Okay, so let me run that cell. Now we'll run this cell, and life should be much better. And we got our 7. Okay, now, lists are very flexible. You can put anything. in a list, which lends itself very nicely to complex data structures. So for example, here's something called AnyList. AnyList has a string as its first element, a float as its second, and a bool as its third. And so if you pick out the third element, remember 2 would be actually that element, it comes up as true. You can modify this. You can actually even make it more complicated. You can make it so that there are different levels of nesting here. So it's a string, a list, and then this list of lists, mmap, that's this right here. So I'm going to run this cell just so we can have all that. Okay? And now when I look at this, you get this more complex structure. So now if you wanted to, I'm going to erase this because I filled in information I really don't want to share with you right now. Okay, so now let's suppose we want to pick out, remember the 7 we picked out before? Let's get that again. Okay, so how are we going to do that? We've got this list and this any other list. So we know we're going to do something with any other list. We know we've got to have a square bracket there. So the first thing is to pick the top level list. So it's the first, second, third top level list, which means we put in a 2 here. Remember that? Okay, and now we can actually cheat because what we've got here is this is mmap. We want to pick out 7. We picked out 7 before. What did we do to get 7? We did this. We picked out the 0, the 2, and the 0 there. So let's just do that again. We'll just add that on to list. Okay? And we run this, and we get our 7. So hopefully that's all clear. Knowing how to address in a language is really important. You've got to be able to pick out variables and assign them. Now, there's a lot that you can do with lists. And this is where there's sort of a conceptual difference that we'll amplify in the next lecture. And that is the way Python thinks of data is packaged with its operations. And this is the core concept behind object-oriented programming. You package data with its operation. And so you remember before that in MATLAB, if we had a function that we were applying to something, like a count or an inverse or something like that, we would say count of, and then we would give the argument as the data. And that function could apply to any data. Well, in MATLAB, in Python, this works differently. So, for example, the list, a list, and these are any other list and any list. These are all examples of the data type called list. Let me add one in here, another column here. If you say in MATLAB help, and you give a data type, or you can give a variable name too. Call it any list, right? Because that variable has a type, and it just looks for help for that type. And we run that. Did I not? Oh, I didn't run that cell. Okay, let's call it any other list, because we've run that cell. Okay. So what it does is it says this is a list object, so it knows that any other list is a list object, and then it itemizes what are called the methods. Methods are operations that can be performed on that particular type of data. So anything that's a list, you can do these things on. Now, for now, I'm going to ask you to ignore all of these operations or methods that begin with a double underscore. Those typically are internal to that data. And so we don't use those outside. The ones you're interested in, it's sort of too bad they don't suppress these double underscores. The one you're interested in is the ones without the double underscores, so append. Let's work with append. So append is a method or an operation you can perform on a list. So let's go back here. And remember, we've got any other list. I'm going to actually we'll go down here, I guess. Okay, so we've got any other list. Any other list is a list. The operation append applies to it, and so we can get rid of this. We're going to append something to it. Let's say append means add to the end. Let's say we're going to add A, B, C, D, E, ... That's what we're going to add to it. And then we're going to run that cell. And we see what we've done here is we've added to the end of the list that string, A, B, C, D, E. so on. So let's say we could add other things too. Let's say we're going to add the number 55. So I'm going to add it once. Okay, I'm going to add it a second time. I'm going to run this again and get it a second time. Okay, and okay, let's see here. Get it a second time. Okay, so now I've got it the second time. Okay, now here's another, if we go back here, there's another method here called count. It's the one after append. And what count does is it counts the number of times that a particular item occurs in the list. So let's count 55. So how many times does 55 appear in the list? Okay, ignore that output because that is from the previous time. Twice. Now what happens if another one of these methods is pop? It removes whatever the last thing is that you put in. So if I do a pop on 55, you see that the output there is 55. And now if I print any other list, so let me see here. I'm just going to, I think I may be confusing things by leaving the leftover stuff there, but let me run that cell so it's very clear what I'm doing. So I'm going to say now print. Remember what I've done is I had the list here with 55 and 55. I did a count, so there are two of them, and now I'm going to do, actually, you know what? Let me just do a count again. All right. So I'm going to count it again after the pop and see how many there are. Okay, not surprisingly, there's one. And now if I add this another line here, and I say print any other list, we run that. I have to spell it right. If I don't spell it right, it does not work right, any other list. And I print that. Okay, and then you see there's only 155 left. Okay, so hopefully that's clear. This is the help on the list. All right, so that's lists. Very powerful data structures, somewhat analogous to MATLAB arrays if you've ever used them, but I would say this is sort of the bread and butter data structure, and you can do things like sorting, and you can remove stuff, you can find positions of things. You can find examples of these on the web. There's a variation on lists. Let's do this again to delete some of this stuff here. Okay, run that. Okay. So one of the things you'll quickly run into is that you would like to create your own list, especially variations on sequences of integers. That's really, really common. And so there's a function, and so not everything's an object. Some of it is are functions. Python does have functions that allows you to generate a sequence of integers. And the way it works, and this is a nice feature, what you're seeing here is actually a feature of IPython Notebook. It's telling you what to enter in as the arguments. It says, well, you know, if you just want a list of integers, you know, through a particular number where you should stop, you can just type in the number. That's what the stop meant right there. And then you run this. And what it does is it starts at 0 with successive integers and tells you when to stop. Stop at 5. Okay. Now, if we did add another line here, suppose we can do this more generally. Range can be used more generally. And it says you can also put a start and a stop, and even a step size. Suppose we wanted to start at 10 and stop at 20. We want the last number in the list to be 20, so we can't say 20. We've got to say 21 because it would stop at 20. And we want to go by 2s. So let's see what this will give us. Okay, so it gives us 10, 12, 14, 16, 18, 20, like we expect. Now, a nice thing about this is now we've generated a list, and since a list is really the basic data structure you use in Python, it's a great way of generating those. Okay. Now, lists are not like MATLAB arrays and matrices in the sense that you can't do computations in the same way. So, for example, common thing is you want to evaluate a function over some range of floats, like, you know, 0.1 to 0.3. And you could write them in there and do 0.1 through 0.3, and that's not too bad. But suppose you wanted to do it from 0 to 5 in units of, let's say, 0.1. Well, sort of intuitively what you'd like to do is this right here. For do a range from 0 to 51, that gets you from 0 to 5. And then you'd like to multiply times 0.1. But you can see that actually gives you an error because the way that lists operate, they don't provide that automatically. We'll return to the problem of manipulating array-like objects later. It turns out there's another kind of data type in Python called an array, not surprisingly, that will allow us to do this. For now, let's move on to another sort of principal data type that's used widely in Python in many software engineering efforts. That's called a dictionary. And what a dictionary does, it provides a way of constructing a kind of associative memory. So we see an example of this in this cell over here. It's labeled 3. It's just under this heading of dictionaries. The way you describe a dictionary or you define a dictionary is with these braces or curly brackets. And you assign values, as I'm showing here, for example, associated with the value first, and it could be any kind of what's called object in Python. And then you make an assignment to it, and again, what you assign can also be any kind of object. So give some examples here. There's one dictionary, what's called the key, is first, and it's assigned a value of 1. The key of true is assigned a value 2. And if we print that out, we see the way it's sort of the formatted version of this dictionary, and that shows the key, which is the print string for the object, in this case true, a colon, and then you see the assigned value 2. So what we're shown here, you can actually describe a dictionary using directly the form that's shown right here with that kind of construct. So I could do like AA equals, it's another dictionary. Say the first value is 1. We're going to assign the value, so that's the key. And the value here is, let's say, 1. And then you put in a comma for the next entry. And let's say this one could be, like I said, any kind of object. Let's actually use that other dictionary as the key. And it has a value, let's say 34. Okay, so then I can enter that cell, and I have okay, all right. So this is actually a good example here. Actually, you can't use any key here. I used A as a key, and what it's telling me here, and this is actually my mistake, but it's a useful thing to know and to find out. You should have to find these things out. The object has to have a characteristic called hashable. It has to be able to index it in an associative way. The list, the dictionary A doesn't have that characteristic, so I'd have to pick something else. And for right now, let's use, we'll use another Boolean, false. That will work. Okay, and so I've now defined this list A, and if I add another cell below this, or the list AA, I'm sorry, the list AA, and so I can do this in the same way as before. I can reference elements of it by the key. So the key for this first key here is 1. And this is not that it's the first object in that dictionary, it's just that's the key value. And if we take a look at that, that will turn out the right value. And then similarly, if I put in the value that the value here is false for the key, and then the key is false, then the associated value is going to be 34. So that's basically the way you use dictionaries. Dictionaries are extremely useful when you're collecting and associated information. For example, the application that we did of doing translation of a sequence of nucleotides in the first class, this is a great way of doing that kind of lookup table, where the keys would all be codons.
and the values would be the associated amino acids. So, and I give a simple example here, and I probably should have looked up to see what CCA really is. I don't know if that's the right amino acid for it. There is, and I'll just mention this briefly, there's a concept of what's called a comprehension in Python. It's a concise way of writing a loop. I'm not going to go into it much right now, but you can look this up. That's what this is here. I'll say this is a comprehension. And I probably should, the way you indicate a comment in Python is with a pound sign. So I won't worry about that. Okay, let me go on to one other data type that's useful here. It draws on something else as well that I'll get to later, and that's the notion of a package. The data type this is an array. It's comparable to, there's actually a data type of the same name in MATLAB called an array. And actually has some similar characteristics. I think an array in MATLAB is actually most like a list in Python. But what an array in Python will let you do is it will let you do a lot of the manipulations that are sort of natural for numeric kind of analysis. So if you describe something as an array, as I did here, now first thing you have to know is that array is not a type that's defined in the base Python. You need another what's called package. If you've installed Anaconda, that package is available to you. But you have to install Anaconda first, or something else that contains either SciPy or NumPy. We'll get back to this a little bit later on. I've given a particular way of including that package. The way I've included this package, the names within that package are directly available to me. So I don't have to prefix the name array, that type, with anything else. There's other ways of doing this I'll describe later on that actually require you to prefix it. And the reason is that you want to sort of separate out your namespace so you don't get what are called collisions, using the same names for different purposes. But once I've done this first statement here, from SciPy import star, then the name array is available to me. Array takes as an argument a list, which I've got in there, and now that list, let me do this a little bit differently rather than showing it like this. Let me just run this cell and you'll see what the list of the X then looks like. Okay, I guess I need to print X, print X. Okay, so that is, it sort of looks like a list. The difference is that there's no comma there. You can always, if you're not too sure what type something is, Python has a verb that actually can take any object as an argument. So if we say, what is the type of X, and then we run that cell, it tells us what it is. So the reason why it says numpy dot nd array for this array type is that SciPy actually includes NumPy, and this type array is actually provided in NumPy, not SciPy. This is, again, we'll have a later lecture about packages, because packages are a whole discussion in and of itself. Once you have something as an array, so X is of type array, then you can manipulate it much the way that we found convenient in MATLAB. You could do something like 0.1 times X. And that will actually do the natural thing of providing multiplication by all of them, all the elements, and you can address members of the array. Let me do this. I did that in the wrong place. You can actually address members of the array just like you would for lists. So if I say y equals 0.1 times x, and then if I look at y of 0, okay, and that does the right thing. Okay? All right. So let me go back to the slides and we'll sort of briefly summarize. I went through most of that material in the slides. I did that interactively in the Python environment here, the Python iNotebook environment. If we go back here, we go back here. Let's see, we've gone through, go back, top here. Okay, so I talked about lists, about how flexible they are, the things you can do on lists. Other operations are what are called methods you find by, you can type help list, so that's help, and then list is actually an argument of help, if you want, whatever it is you want to look at. I talked about range. I do that, and we just talked about dictionaries right now. Okay, well, let's move on to conditionals. So I've spent a lot of time on data types in Python because that's where a lot of the richness of Python has to do with the data types. And the other thing is that I mentioned the philosophy of Python and other object-oriented languages is that you package the data with its operations. And so although we've been talking about types, the fact is that the types actually come with particular operations too. So we've come, what our discussion, for example, of built-in functions in MATLAB. I mean, that's really superseded in Python by this notion of the methods associated with a type. Now let's talk about conditionals. Conceptually, there is no difference between a MATLAB if statement and a Python if statement. They're really conceptually the same thing. And that you will find that in almost every, well, certainly every procedural language. And we'll talk about a non-procedural language later in the course called SQL, the structured query language. It's a different kind of beast. It's just, it's done, it has different interpretations and semantics. You don't find the same thing there, or not in the same way that you do in a procedural language. But procedural languages like MATLAB, Python, Java, JavaScript, C++, Fortran, they all have if statements, but the form of this if statement, the syntax, the way you express it, it's different, and you just have to know that. So let's go through it. Like in MATLAB, case matters. You lowercase I, lowercase f, and then the syntax is done differently. So in MATLAB, you would see a block that has if, possibly an else, and then an n. In Python, this is done by indentation. So you have the if, you have the condition, this is a Boolean variable, and then it's a colon. The colon delimits the end of the if statement. And then the block is indicated by indentation. So it doesn't matter how many blanks are here, but they have to be the same number of blanks for each element in the for each statement in the block. Okay, so with that background, I am going to switch back to the IPython notebook. I'll do that for lecture 8. Okay. So, we talked about addressing elements and lists. Conditionals, yeah. All right. All right, so here's an example. We've created this Boolean variable b, and obviously, 1 is not greater than 2, so the value of b is false. Okay, so we know what that is. And the if statement, you can add if and else, just like in MATLAB. So if b, well, b is true. If b is true, then we print hello. Otherwise, we're going to print goodbye. And why do we print goodbye? We print goodbye because we know that b is false. So that same logic holds. Now, one of the observations here, and that's what's going on in this cell over here, is to reinforce this idea that all statements within an if block must be indented the same amount. And if you don't do that, you get an indentation error. When I fix that indentation error, like I just did there, and then run that cell, things work. And so I've got multiple statements in both the if and the else. Just to make sure this is very clear, I don't have to have 2 statements in the if block. You can have an uneven number. That have to be the equal number of statements, so you can do that. So, okay, that's interesting. So the question is, why does that print hello? What is b? Okay, let's figure this out. That's a good question. So you see, this is sort of a surprise to me because I print hello here, but B is B should be false. What is B? See if we say print B, what do we get? Ah, interesting. Okay, we have reassigned the value of B. Oh, I use this in my matrix. Okay, so this is an interesting point. It's also an interesting point in terms of using IPython Notebook. Have to make sure you run the cell. So what do I assign to B is very different than what would have been apparent here, because I did not actually run this assignment statement. So now I ran that. If I run this now, I get the right goodbye. If I print B here, B should now be false, just like it was up here. And now if I run this, I should get the else. There is some complexity and subtlety associated with how non-Boolean types are interpreted, whether they're true or false. Generally, something which is unassigned, like has the value none, or is 0, is treated as false. You have to be careful about this, and it can vary with language. But that's, other than the subtleties associated with the conditions, the main thing about the conditionals is that just the syntax, the concept is exactly the same as in MATLAB. Right? Let's move on to iteration. Okay, well, iteration in Python is done in a conceptually different way than what we saw in MATLAB. So in MATLAB, the way we iterated was we had a loop variable, and that loop variable would take on values, integer values, over some range, and we could, vary the range, and we could vary what the sequence was, maybe by, stepping by different amounts. Instead of going 1, 2, 3, we could go 1, 3, 5, or 1, 11, whatever. It depended, but that was the basic concept: is that you're taking integers and you're determining an integer list. In Python, the idea is different. In Python, what's happening in a for loop is that you are iterating over values in a list, and it's actually a little more general than a list. It's anything that's of a type called iterable. And what that means is a little subtle. I won't get into that for right now. Just think a list. Okay, so anything that's a list, and what you're doing in a statement like this here. So here we've created this list called a list. And a list, list can be of mixed types, so that's what this is. We've got this thing of mixed types, and I will actually run that cell so that it's actually been assigned. And when we say for x in a list, print, and I'll do this a little differently just so you can see that actually something is executed here. Print x equals, and this is actually sort of interesting. You can assign, this is a format statement, is what's going on here with the print before we've just printed individual variables. The thing in quotes is the format description. So this is just text. Anything with percent in front of it indicates what it is you're going to, the format of what you would like to print out. In this case, I have a single value x, and the percent here separates the format part of the print statement with the values. And so we can get rid of this too. Okay, and so now if I run this cell, it gets tells me what it is. It says that x equals, and then percent s means that interpret this x as a string. Okay, so we go through this list here. So we've got this string lowercase true, the Boolean true, its print string is just true, and then we've got x equals 1.2. Okay, and so what the loop does here, so you can see the format. We've got for. We've got a loop variable, just like in MATLAB. In this case, it's going to have a different interpretation. We use in here, and then we've got the list that we're iterating across, and of course, it's a colon. Just like in the for statement, all of the blocks in Python have a colon at the end of the first statement of the block. And the interpretation is we have available this loop variable inside, and we're using it over here as a value in the print statement. And we're running this print statement for every value of x in a list. And that's exactly what's happened here. Now, of course, we could have multiple multiple values in the for loop. So let's do a little more here. So suppose we said for, and the value, the variable we use in the for loop, it's really up to us. Call it y this time in a list. Let's do something a little bit more. IPython notebook automatically indents, which is sort of nice, so I just pressed return there. Let's say that these are different types. So it's, well, here's something. We'll do a little string manipulation. Let's say that z is equal to y concatenated. Well, let's say, how about this? Message is equal to this is y, and then we'll put a colon there, and this is all in the format string, and then okay, this is y. I want to have two values of y here, and this is also y. I'll do it again. Okay, so in this case, what I've done, it's sort of silly. I've done I'm going to print y twice in this. It's part of the message. The percents here are essentially variables that exist in the format string, and they have to match what's present in the values associated with this description. Because there's more than one, I have to enclose them in parentheses, and I separate them by a comma. So it's just y twice is all this is. And so how many lines will I have here when this prints? And think about that. It's one line for each. Oh, I haven't printed yet, so I'm going to do that print message. Okay, and the parentheses around the argument of print are optional. Many style guides actually recommend that you don't include the parentheses because it clutters things a bit. So I'm going to have, when I print here, this loop will execute for 3 times, 1 for each member of the list, and each time I will print this, and every time I print, I will get the value of that list element twice. So if we run the cell, see what happens. That's exactly what happens. Okay. Now, I mentioned before, if you wanted to get functionality similar to MATLAB, basically what you want to do is get ranges of integers, starting at some value, ending at some value by some step. And so, yeah, you can do that. If you've got, we've got this matrix MMAT. You can take, well, I'm going to change this a little bit, call this I instead of X. It just sort of makes more sense. We want to print out the rows. Remember, it was a 3x3 matrix. We want to print out the rows of this separately. Then we want to index across all the rows. So if you remember the way range works, it starts with the first value that you're going to use in the sequence. And it tells you when to stop. So this means don't use 3. And by default, you're incrementing by 1. So the result is exactly what we see below. Suppose instead we're going to increment by 2. What will we end up with then? Know that? So we get the first row, which is 0. We've added 2 to that. And we should get this row, the third row. We shouldn't see the second row. That's what we should end up with. And actually, what I'm going to do is rather than doing that here, let me leave this as is. And actually, I'll make that explicit. Call that a 1. Let's create a new cell here. And I'll put in this value over here that we just did. So now we're incrementing by 2. We should end up with 2 rows rather than 3. And it's the first and the third row. Okay. Okay, so hopefully that makes sense. All right. So that's iteration. So let me just check back in with where we are in the slides. Okay, so I mentioned before with conditionals. So let's continue with Python scripts. Python scripts are conceptually, and even for that part, almost syntactically the same as MATLAB scripts. You put code in a file, and you invoke it with the command Python instead of Octave or MATLAB. The file name generally has the extension py, and it runs in that environment. So really just the same thing. Let's go on to functions. Functions are sort of at the core of what it is that you do with software engineering. You organize code so it can be reused. You think about what the arguments are. You think about the return values are. And so with Python, it's exactly the same thing, exactly analogous to MATLAB. But the syntax is quite different. And so to show you an example of a function here, here's a function. I'm doing this in the Python shell. So we see the 3 carets here. The way you describe a function is you declare it by using the statement def. So def, then you give the name of the function and its arguments. Unlike MATLAB, there is no return value specified. Instead, you have a return statement. So in this case, what's going on is we're running this particular loop, mylist, on mylist is passed as an argument and printing each value of it. So let me go to the IPython notebook again. Go back to that. Resume there. So with functions, I mean, here's an example here of a function. Again, def to define the function name, and then the arguments. In this case, there are 2 arguments instead of 1. They're separated by parentheses. That's the same as MATLAB. Always have the colon at the end, and then the function statements in the function, the block. As before with the if statement and with the for statement, it's based on indentation. So if you have more statements here, you have more indents. And so let's see, let's declare this function. I'm going to run that cell, and now we're going to do the division. And that's what we've got. And again, you have to have the explicit return. Okay. All right, so now you've got the equivalent characteristics, equivalent features for MATLAB. You've got those in Python. So now let's go back to something we did in MATLAB and translate it into Python. Okay, so the first thing you need to know, we're going to do the prime numbers, so we're going to look for prime numbers. First thing you need to know is, remember in MATLAB code, show this over here, there's this mod statement right here. So all I did here, this is just the text of the MATLAB code that we did. Actually, let me make this on a separate line, hopefully. All right, and run that. This is a markdown here. This is not code. It's just treated as text. Oops, what did I do here? Let's revert that. All right, no, I guess I'm going to have to do it differently. Let's go back here. And yeah, so this is supposed to, the single quote here is supposed to indicate something that is a code. There we go. Unfortunately, I don't get this on a separate line. I didn't do that right somehow. In any case, here's the MATLAB code. What we're concerned about is right now we're going to have to do this mod statement to test for divisibility by a number. So this mod div, n tests if what is the remainder of dividing div by n. So the way you do that in Python is with this percent operator. So 6% 3 means the remainder of dividing 6 by 3. So that's a 0. 7% 3 is 1 because the remainder of dividing 7 by 3 is 1. Okay, so with that in mind, we're now set to translate this MATLAB code. So the first thing you might think about is let's go through line by line. You know what I'm going to do here? I will, it says MATLAB code. Let me do this a little differently. Let me add a line here and just call this, say that what follows is MATLAB code. All right, and we'll call this is going to be a markdown. And then that way I can eliminate that here. And we can just see the code rather than this other stuff, which makes it look sort of strange. Okay, so now we've got the code itself right over here. Great. Okay, so let's do this line by line. If you're going to translate this into Python, let's see the statement div equals 15. Well, that looks like a perfectly good Python statement. It's an assignment statement of the integer 15 to div. Okay, how about this statement here? Max divisor equals ceil of square root of div. Okay, well, we've got to find the equivalent functions for square root and ceil. And in MATLAB, it turns out that there is something called square root, which you can apply to a number. And ceil applies as well. The difference is that ceil is the floating point ceiling, and we want the integer ceiling. So that's the way we translate that there. This statement here, answer equals yes. Well, that's the same. Okay, then we get to the for loop. Now, we know that the for loops are different. So in this case, if we're doing a direct translation, we want to get a list of integers from 2 to, this is will be an integer up here. And the way we're going to do that in Python is we're going to use range. Since range is an integer, we're going to go from 2 to max divisor. We've got the if statement over here. Well, we're not going to use mod because mod is a MATLAB function, but we use this percent operator. So what we're looking for is div is divisible by n exactly, which means it's equal to 0. Answer equals no. Okay, we've got an end statement here. That doesn't exist in Python because we use indentation. The end statement for this block doesn't exist. And disp the answer, we're going to instead print. So let's see what happens when we run this. Okay, so we get that. So if we change this from 15, so we're checking to basically what this code is doing is checking to see if 15 is prime. If we did this for 17, all right, then what would happen? Let's see. We get a yes. Okay. So that's an example of doing this. I mean, again, the key thing is to watch the loops and the for statements. The loops, the for statements and the if statements. Those have a different syntax. They have this colon, they have the indentation, they don't have the end. Otherwise, the translation is pretty straightforward. All right, let me give you one more kind of capability in Python that you're going to want to use, because the homework is going to be to take the Michaelis-Menten analysis that we did in MATLAB and instead do that in Python. Actually, two more things you're going to need. One of which is the matrix is what I'm going to show you right now. So remember that part of the analysis was, we had to fit a line using least squares. So we did this through matrix manipulation. So remember this the statement here, the from source import something. I'm going to go back to the slides in a second. We'll discuss that a little bit more, what these imports do. This is a way of bringing in additional code or features that will help us with the programming. So the way this is done is any name in NumPy now becomes a name in our environment. So matrix is such a name. And we can define a matrix, much like it's in MATLAB. We remember in MATLAB we would have this as a we would do this as a sort of a blank separated list and then semicolons for different rows. So these are this is columns within a row, new row, columns within a row. The way this works in with this matrix object is that use single quotes, so it looks like a string. So here we get two matrices, and we can define the matrices. You could do a transpose of the matrix. So let me just leave this code as is. I'm going to create a new line here, and I'm going to take parts of this. So let's just do this. I'm going to take that piece there. Okay, so from NumPy import star means it gets us all the names in NumPy. Matrix is one of those names, so we can run this cell. Okay, now matrix is there. If we get a new cell, I put it down too low. Get this new cell over here. Now if we say a.t, that's the transpose of t. So first of all, let's print a, and then let's print a.t, which is the transpose of t, of a, sorry. Okay, so we've got two different things. We've got, here's a, that's 1, 2, 3, 4, which is what we would have expected. And the transpose of it is the column, the first row becomes the first column, the second row becomes the second column. So that looks good. That's what we would have expected. Okay, now we can also, I'm putting it in the wrong place. We can also do things like we can do matrix multiplication. So let's say we've got this matrix X over here. I'll just type it in. X equals a matrix, and it is 5.0 and 7.0, right? And then we can do something like print A times, oops, I didn't want to do that because I liked, oh, okay, yeah. Okay, and I'm going to say y is equal to x dot t. Okay, so now, well, it was a 2 by 2 matrix before, so that still works. Okay. So this is a, so x here is a 1 by 2. I want to multiply this by a. So if I'm going to do A times another matrix, it better be a 2-row, 1-column matrix to make it compatible, well, at least 2 rows to make it compatible with the number of columns in A. So when I'm going to do, then y is the transpose of x. So if we do this, then actually what I think I do is then, let's say we're going to print y. See what we've got there. Okay, and that's what we expect. And then, keeps on giving me in the wrong place. Okay, so now I can multiply this matrix y times a. It makes sense to print a times x dot times y. That makes sense because I've got the columns lined up right. Okay. And the last thing I just point out over here is that you can compute the inverse of a matrix. So obviously the inverse of the matrix times the matrix should be the matrix with diagonal 1, and off diagonal all other elements are 0, and that's what you see here. So that gives you really all you need to do to compute the least squares estimate going from MATLAB to Python. For least squares estimate. The last thing you need to do here is you need to do graphics. And so there is another package, which, let me switch back to the slides and sort of go through where we are right now. Okay. It's another package, another one of these imports. So here we went through the Python functions. We did this example of the converting the MATLAB code. Okay, and we did that in the spreadsheet. Okay. So before I talk about the graphics package, let me talk about packages in general. So what a package is, we've seen this a little bit before. We've seen NumPy, for example, and there's some other packages, something called math. What it is, it's a file with both executable statements and functions you want to include, embed into your environment. And this is really the way you extend what it is you can do in Python. So this is package math. And this is what it describes. It has functions like cosine and arc cosine and the like. And so the way you use it, and this is the most important part, what I sort of skipped over before, is that first you have to install the package. And this typically involves downloading it from a site. There are various tools you can use to do this. If you follow the software tab from the course webpage, it will give you details for Anaconda. And the second thing is, now that the software, the package is installed on your computer, then when you write a Python program, you import the package that is already installed. And this brings it into your environment. Okay. The question is, and this is something I sort of glossed over, is how do you reference the functions and the types that are present in the package? So there are a few possibilities, and this is what's called importing a package, the way you get it so that you can reference it in your program. The first thing is that you can put these names directly into your environment. For example, the package math has the function cosine. And if I use this form, which is what I've been using in the IPython notebook, if I say from package name import star, it takes all the names in that package and puts them directly into your environment, just as if you had written those functions in your environment or those types. And so, for example, the function cosine is actually part of the math package. If I had tried to use cosine before I did this import statement, I would have gotten an error. Now I can use it because I use this import statement here. So that's one approach. Now the downside, in one sense, this is nice because it's convenient. You just use the same names of the package. It's very natural. The downside is that you may have names in your environment that conflict with the names in another environment. I mean, things like plot are widely used. You may have your own plot function, and so you don't want to confuse it with, the plot function in the matplotlib package. So here's another approach that you can use, and that is if you just say import package name. So that's different from up here, from this package name import everything. Import package name, that brings everything in, but it makes all of the names are put under this name math. So then if you want to reference cosine, you would say x equals math dot cosine, because math is a high-level concept, a high-level name, and then cosine is under. And the variation on this is that you can have this notion, and what's nice about this is it prevents this problem of name collisions. And the variation on this is if you don't want to use the full package name, because some of these package names are sort of long, you can use this form, import package name as, and then you give some shorthand like M for math, and that's how you reference it. Okay, so that's really all you need to know right now about how to import packages and the different ways of doing it. So let's give an example here. We're going to use matplotlib as our example, and let's see, that is a package that's available to you if you get Anaconda. Okay, and so let's go back over here to the IPython notebook, and now we're going to start making some new cells here, and I'm going to call this section. I'll make this available on the website too, by the way. Let's call this heading. We'll call this plotting, and we'll run the cell, and then that looks really nice. Okay, great. So now we have this plotting. So the first thing we're going to do is we're going to import. Actually, what I'm going to do is, I'm going to import matplotlib as p. So now I'm going to have to preface all the functions of interest to me in matplotlib with p dot. Okay, so let's make sure I've got that. Okay, now the fact that Python didn't complain means that package exists. If I said import garbage as g, Python will complain because it doesn't know about the package garbage. So now we're going to continue on with plotting. So now that we know how to import packages, one of the packages that you'll want to use is the pylab package. And there are variations on this. There are ways you can get to matplotlib, use matplotlib as well, but pylab is particularly convenient. So I generally prefer to use this form of an import that I'm showing right here, where I reserve a prefix for a package so that I don't have name collisions. This cell right here, this cell that says matplotlib inline, what this allows me to do is to get the graphics in the IPython environment, and that's very convenient. So let's run this cell, make sure that that works. And we'll run this cell to make sure that that works. And now we're down to the plot. So here's a very simple plot. Plot has the form. Actually, let me do this a little bit differently. We'll just clear that out. Let's have an x and a y. Let's say that, let's say x is equal to 0.1 times array. Okay, so remember, put that just into our namespace from NumPy of, let's say, range of 0 to 51. All right, I think that ought to work. So that's going to give us from 0 to 5.0. We're going to get, because we're going to multiply by 0.1. That looks good to me. All right. And so then if I say print x, what have we got? Print x, yep, we've got what we want. Okay, that's good. Okay, now on my y, which will also be an array, is going to equal, what happens, not sure exactly how this is going to work with the arrays. Let's see if I can do this. Will this work? This is a good thing to try. See, that doesn't work. Doesn't know what that is. Is it a matter of this? All right, so that actually works. So, so this is also a good thing to know. Different languages will have different ways of describing exponentiation. So that raised all the elements of x to the second power. Let's see what that looks like now. Is that our y? Okay, that's what we've got. Okay, so now we've got a quadratic here. And now I'm going to plot x comma y, just as you would have done in MATLAB. Looks the same way. And we get to see the curve in this environment in MATLAB. And so that's very convenient for interactive development. Okay, so now we have a way to do this. And if we go back to the slides and give more descriptions in the slides about how you might do this. It actually uses one of these comprehensions to do it. Let's see here. Yeah, shows you the comprehension. Okay, so and then you've got various other things that other related packages you can look at. Matrices we've actually already gone through. So the one other thing that you'll have to look up here is if you, and this is a good exercise for you, because you're going to want to do labels on plots. So I didn't show how you labeled, get an x-axis label, a y-axis label. You're going to want to maybe change fonts and stuff like that. All that's available, and what you need to do is look at PyPlot or MATLAB Python plot. Probably just look PyPlot plus x-axis labels, and then you'll start to find out how to do this. So I will leave that as an exercise for you, although I will illustrate one thing. Let's do it for x label. So x label and plus PyPlot, because that's pretty specific to Python. And we should find some information. Here we go. This is even better. This is a PyPlot tutorial. It should show us how to do all the things we want to do. So, okay, so we actually are getting the show automatically. But here's an example here, Y label. So what we apparently have to do, remember, see, this is using that import as structure. And we use P, it uses PLT, and says just call X label or Y label is the way the label is. So let's go back to our Python notebook and go back here. I didn't click very well, did I? Okay. Oh, I'm in the environment. Sorry, I'm already here. Okay, so let's try this again. Let's say that p dot y label is y label. And then if we run that cell, what happens here? Okay, that gives us y label. So in order to get the plot label on and do the plot itself, you use a sequence like this. You first do the plot, then you append the label, and then you do a show, and that redisplays the plot. So let's see, since I've already got this, this is, actually, you know what, I'll bet that we can put an X label on here too, just by doing really the same thing. Let's call it X label. Oop. X label, X label. All right, now if we run that cell, we end up with a Y label and an X label. Okay, now you've got the idea. All right, so going back to the slides here, let's go back to homework. Okay, so for the homework, what we're going to do is you're going to redo the Michaelis-Menten kinetics in Python. And tell me a little bit about what was hard about that. All right, well, that's it. And hopefully this is enough information for you to get going.